Let's take a look today at how we can solve inequalities and use some properties to justify our steps in solving as well as graphing. Let's keep in mind what an inequality is. An inequality is a relationship between two expressions. It's one of our open sentences, and it contains the less than or equal to, greater than, or greater than equal to symbol. Solutions to inequalities are values that make the inequality true. There are infinitely many solutions to an inequality. In order to find our solutions, we use axioms of inequality, which are basically properties that allow us to do each step. So reviewing, we have a few different properties that will look very similar to those for equations. We've got the transitive property of inequality, the addition property of inequality, and the subtraction property of inequality. Those are very similar. However, with multiplication and division, these properties have a little bit more detail in them. And what they do is if you end up multiplying or dividing with a negative number, your inequality symbol will flip places and change to its opposite direction. Let's take a look. There's almost nothing different in solving an inequality as there is in an equation, except for when you multiply or divide with a negative number. So let's take a look. So here's my first one. I've got x minus 5 is greater than negative 3. That's my given statement. We solve just like we normally would. We would go ahead and add 5 to both sides. That would be our first step. And that's step 2 right here. And that's using the addition property of inequality because we're using inequality symbols. Then we go ahead and simplify and we get x is greater than 2. I might remind you that we do know how to write it in set builder notation. So this would be x such that x is greater than 2. How many solutions are there? Well, there are infinitely many solutions to this. And the solutions are all going to fit this inequality statement at the end, where x has to be greater than 2. So you can come up with a whole bunch of numbers that are greater than 2, and they'll all be solutions to this inequality. When we multiply or divide with a negative number, that means that coefficient of x is negative. We're going to need to flip our inequality symbol. So let's take a look. We've got x greater than negative 3x minus 7. We'll take this step by step. Our first step is going to be to add 7 on both sides. And that's what you see in step 2. That's our addition property of inequality. And then we just go ahead and simplify for step 3. We get 15 is greater than negative 3x. Well, my next step would be to divide by negative 3. So here we go. We're dividing by a negative number. So we have to go ahead and switch our inequality symbol. The symbol switched directions. And we simplified. We got negative 5 is less than x. Most of the time, you will see the variable written on the left side of the inequality symbol. And this is very helpful for graphing. So at this point, we're going to just rewrite the whole statement backwards. So I have x. See how this open part of my symbol is towards the x? When I rewrite it, that open part of the symbol has to be towards the x. So I've got x is greater than negative 5. In order to check, I need to pick a value that would make this statement true. X is greater than negative 5. When I'm working with inequalities, if I can choose the value 0, I try to use that. So I'm going to pick that one. If I'm going to check my solution set, that means I'm going to pick a number here that would be true, and 0 is greater than negative 5. So I'm going to choose 0, and I plug it back into the original inequality statement. So for x, I'm going to plug 0 in. And then I'm going to go ahead and simplify. So let's see. 8 is greater than negative 3 times 0 is 0 minus 7. So is 8 greater than negative 7? Is that true? It is true. And if it's true, that means that 0 is a possible solution. So it looks like we've got our inequality correct. When we're multiplying or dividing with a negative sign, why do the signs reverse? Well, let's take a look. When we multiply by a negative number, we change which is bigger and which is smaller. So for example, I have 5 is greater than 3. If I multiply both sides by a negative 1, I'm going to end up with negative 5 is greater than negative 3, but that isn't true. Negative 5 is actually less than negative 3. It's further to the left on the number line. So when we multiply by a negative number, our symbol needs to flip to the opposite direction. So that's why it works. So go ahead and see if you can go ahead and complete these problems. Use set builder notation to give your final answer. Pause the video and see how you do with solving these inequalities. All right, take a look at your answers here. We get y such that y is greater than negative 16. For letter B, y such that y is less than 6. We had to switch our inequality symbol here. On letter C, we had to do the distributive property first, then the subtraction property, simplify. We get w is less than negative 12. On letter D, I combined some steps here, but I added 18 to both sides, so that would be the addition property of inequality. And then I subtracted 17x, so that's the subtraction property of inequality. Then we divided by negative 9. That division by negative 9 means we need to switch our inequality symbol from a greater than to a less than, and we'll get x is less than negative 3. How do we graph an inequality? So let's remember how to do this. If I have the statement x is greater than 2, at the number 2, I'm going to put a circle. And then I have to make a decision. Is it going to be an open circle or a closed circle? A closed circle is when a boundary point is included, and an open circle is when we are not including it. So let's see. If I look at my symbol, it says greater than. So my numbers have to be greater than 2. But I'm not including 2 because it doesn't say greater than or equal to. So if it's just a greater than symbol or a less than symbol, we're going to use an open circle. If it's greater than or equal to or less than and equal to, then we go ahead and fill in our circle. So this one, x is greater than 2, is going to be an open circle. And then I want to draw an arrow showing where all the values are that are greater than 2. Well, all the values that are greater than 2 are over here to the right. It helps when I have my inequality written with the variable on the left because the point of the arrow is the same as this point of my inequality arrow, but only when the x is on, or the variable is on that left side. All right, let's see if we can go ahead and solve this one. So you can pause your video and try it yourself and then graph it. All right, so when we solve and graph this solution, first I went ahead and subtracted 6x, so that's using the subtraction property of inequality. Then we simplified. And the second step would be to divide by negative 16. That's using the division property of inequality. So if I'm dividing with a negative number, then my inequality symbol needs to flip, and I get my solution of x is less than or equal to 1/2. So on my number line at 1/2, and I had to write that in, I'm going to use a closed circle because it said less than or equal to. So less than means go ahead and draw a circle, and then if you have the equal to part, you got to fill that circle in. And all the numbers that are less than 1/2 are to the left. So all of these values here are possible solutions to the inequality. All right, go ahead, you try these two. Pause your video and give it a try. All right, for letter A, we went ahead and multiplied by negative 2. Multiplying by a negative means I need to switch my symbol. Hopefully you remember to do that. We get x is greater than or equal to negative 4. Close that circle up at negative 4 and head on to the right. For letter B, you could have done this in many ways. One thing I did was combine my like terms. So I combined my x's here on the left side first. Negative 3x minus 4 less than negative 4 plus x. Then I moved this 1x over by subtraction. So now I'm at negative 4x minus 4 is less than negative 4. Then I added this 4 to both sides. I got negative 4x less than 0. Careful with your integers. And then I'm dividing by negative 4. So when you divide by negative 4, again, you have to switch that symbol. X is greater than 0. Place an open circle at 0 and head on over to the right to show all of your solutions. We're going to pause at this point for this video. Our next video is going to be graphing and solving linear inequalities with 2 variables. Make sure you practice some more inequality solving and graphing before you move on to our next video.